Hello everyone! Today I will introduce to you the porting and debugging method for the Quectel FGH100M Wi-Fi HaLow module. Now let's get started. In this course we will be covering these 5 sections: Wi-Fi HaLow introduction, porting environment introduction, driver porting, tools porting and functional verification. Wi-Fi HaLow is a wireless communication standard, formerly called IEEE 802.11ah, designed for long-range, low-power connectivity. It operates in the sub-GHz band, offering extended range comparing to traditional Wi-Fi, with approximately 1 km coverage. HaLow is ideal for IoT application, providing reliable connections over the large areas with a low power consumption. It supports a large number of devices, making it perfect solution for smart home, industrial IoT and agricultural monitoring. These two tables highlights the benefits of Wi-Fi HaLow compared to other IoT technologies. HaLow stands out due to its low energy requirements, long-range capability and its use of familiar Wi-Fi standards. Because it builds on existing Wi-Fi standards and practices, it is very straightforward for end users to install and maintain. As an example, we will use the Rockchip RK3568 platform as the MCU to demonstrate the driver porting procedure. The hardware setup consists of Quectel FGH100M HaLow module featuring an M.2 interface and the Quectel SG368Z-AP module, which are hosted on RK3568-WF emulation board. The practice testing the Quectel YENI002AA antenna will also need to be installed. You can see the complete hardware setup. And for the complete testing topology, it will require 2 of the hardware setups. One acts as access point and the other as station. On the software side, we need to prepare the software packages in advance for both the FG100M module and the RK3568 as the MCU. Please contact Quectel support channel for applying the access to the Git repositories. For the preparation of the compilation environment, the following components are required to be installed. There might be other components needed for the compilation machine. Please also install these accordingly. As for different Ubuntu versions, the debugging methods are similar. The source code package file includes driver /firmware /hostapd /wpa_supplicant /morsectel. In this section, we will demonstrate the workflow of the driver porting for the Quectel FGH100M HaLow module. Firstly, we need to acquire the kernel version package related to the RK3568 host architecture. This information can be found in file /RK3568/kernel/makefile and should be used later to locate the suitable kernel patches for integration of the FGH100M module. The second package we need is the FGH100M SDK package, version 1.12.4. Each kernel version of the 1.12.4 driver has its relevant patches. If you are working with a newer SDK version, such as 1.14.1, please follow the same procedure accordingly. The SG368Z platform is based on Linux 4.19, so enter the 4.19x directory. We will see the patch files. We need to merge the following 8 patches as highlighted in blue. The patches for FGH100M module correspond to your MCU kernel version, which in this case is Linux 4.19. Quectel is integrating more kernel versions to cover diverse scenarios. Additionally, we need to incorporate the following 2 modifications into the SG368Z platform. Step 1. Modify the DTS configuration in the Linux source code for the identification of the FGH100M as the I/O device, as follows in the blue font. Step 2. copy the FGH100M driver code directory to the Linux drivers directory. The following shows the FGH100M driver folder and the target kernel folder. The complete folder path is to be determined based on the location where the code is stored. And please note, this configuration needs to be adjusted depending on the specific host platform. Due to the possible parsing issue during build process, do not use copy-paste method to update the DTSI file. Instead, manually type in the modification points. Step 3. Modify the Rockchip_Linux_dev_config. The modifications are to configure the FGH100M driver, as highlighted in blue. Steps 4 and 5. Modify the makefile and kconfig files for the compilation of the FGH100M driver. Step 6. Modify the Python script inside the kernel/scripts folder to fix known compilation errors. After applying the patch files and importing the FGH100M driver, follow the compilation procedure as shown here. First, clean any previous building output and proceed to source build-queq script and the environment setup script, and then execute the build-all-image command to start the compilation. During the compilation, as described in previous compilation environment introduction, if any dependents are missing, please install and fix accordingly. Once the compilation is completed successfully, the firmware image of the RK3568 and the driver of the FGH100M module will be generated into the shown paths. We will use those binaries files for the flashing procedure, which will be introduced next. For the firmware flashing procedure, follow the steps below. Step 1. Make sure the USB driver is installed. You can fetch the driver from the package in the corresponding path. Step 2. Install the RK-dev-tool located in the shown path. After the installation is completed, set the value tool to the parameter name selected under the language block inside the config.ini file. Step 3. Connect a 12-volt power supply. Step 4. Turn the boot switch to the on position. Step 5. Connect a Type-C USB cable to your PC. Step 6. Turn the power switch to the on position to ensure the power supply, and then press the power key button to enable download mode. Launch the firmware flashing tool, rkdevtool.exe. When it detects the development board and it has entered download mode, there will be a note "Found one loader device" displayed on the tool down below. Next, select Upgrade Firmware, then Firmware. Double-click to select and load the update.img file as compiled in previous steps, and then click on Upgrade on the tool interface to start burning the image to the board. Once it is completed, there will be Download Firmware Success printed in the log. Disconnect the power supply of the development board. Turn the boot switch to off, and then power up the board once again. The last step is to press the power key button to boot up the module and enter normal mode. The next requirement is to upload the firmware and driver files of the FGH100M to development board. The name of the files and corresponding locations are shown below. Specifically, a suitable bcf_default.bin file should be chosen depending on the OC details, which can be acquired directly from the product RF Shield. To upload the files to the development board, we will use the ADB tool. The ADB tool is located inside the RK-dev-tool installation folder. Before we upload the files to the development board, we need to create the following directories to the corresponding locations. After the folders are created, use the ADB tool to push the files to the corresponding locations. Before we load the drivers, we will use the kernel log information to confirm that the SDO card is present. After confirming the SDO card presence, we proceed with loading of the module drivers. To finalize the process and confirm the results, we will use the ifconfig command and look for WLAN0 interface. If the interface is found, proceed with the final validation step, using the dmessage command to confirm the driver is loaded successfully. Let's now connect and switch on our EVB. To find out more about Quectel's EVB kit, visit quectel.com. Contact your regional sales team or our channel partners.